m'appelle Tom Winty et je voudrais parler de la matière foncée. Mais je voudrais commencer avec une question. How do we unite the science of the mind-bendingly huge with the science of the infinitely small? Well, we start with a problem. Most of the universe is missing. Now, when we look for our telescopes, we look at the stars, look at the galaxies, look at the black holes, and count these all up. These only account for about 4% of what we think exists. Now, that's a bit weird. That's like having the 90,000 capacity Wembley Stadium filled with about 3,500 people, which is the population of North Ferriby, a small village on the outskirts of Hull. Now, that would look a bit odd, and it is a bit odd. And where is the rest of the universe? Well, if we look at galaxies and how they rotate, and we count the stars in them, there's not enough stuff in there to explain that rotation. So scientists have proposed this extra stuff that must be there, that explains why galaxies rotate like that. And this stuff is called dark matter. And this accounts for some 20% of what we think exists. The remaining 70-odd% is something that physicists call dark energy. Now, what we've done there is we don't really understand what it is, but we've given it a sort of name that sounds quite cool, you know, so I'm a physicist. I control dark energy. Right. Oh, excuse me, what actually is dark energy? So, did you not see dark energy? Yeah, so it's, you can ask me about that later. But anyway, most of the universe is missing. Now, it's all very well looking through telescopes, but in particle physics, we want to do a bit better than that. We want to make dark matter in the lab. How do we do that? Well, at the Large Hadron Collider in Geneva, when we finally get it working, we take protons, tiny subatomic particles of matter, and we whiz these round our 27-kilometre racetrack, and then we smash them together. And this creates a lot of energy. Now, there are certain theories in particle physics that predict giant, massive, but invisible particles, and these are candidates for dark matter. And via Einstein's E equals mc squared, we want to turn this energy into these dark matter candidates. So we then smash the protons together, create these dark matter, but how do we see them? Well, when the protons collide, we have particle detectors, giant digital cameras that measure the energy coming out, and then we know the energy coming in, so we can subtract those two numbers and see that something's disappearing. And that's how we see if we've made dark matter. That's how we link this discovery to the observations of our telescopes, and that's how we link and unify the science of the infinitely huge with the mind-bendingly small. Thank you very much.